So hi, good afternoon everybody. Good afternoon. Those of you in the end, in case you guys choose to come here, you want to come here, please feel free. So I can see your faces, I can put some expressions on the face and then I'll know how it's going. Otherwise it looks too far away. So this session really is about creating data as a service on Windows Azure. In fact, I thought I would actually remove all the frills and fancies which were put up there, including my name. I thought I'll just leave it at the title. Then I came here and I saw that I had a speaker badge which had India and it had my Twitter ID and it even had my company name, etc. So then I thought might as well put that up and then stand here and listen to all of you. So that's that. So that's my Twitter ID in case you have any comments, if you have any questions, clarifications, concerns with respect to Windows Azure specifically, you could write into me because for the last 4 years I've been taking a look at the Windows Azure platform. So the platform was launched 2008 November when it was pretty much like the olden DOS command prompt days where we had to actually write command line tools to do upload, download, stop, start. Everything was REST based and the backend was set. And then came a lot of this rapid application development, frills and bells and whistles across various technologies. Microsoft, obviously, because it's a Microsoft product, those came out first. But then we have plugins for Eclipse. We have plugins for we have drivers for Ruby on Rails, you have PHP code snippets, and so it's completely open today as it stands, Node.js, etc., and some of which we're going to talk today. So without any due delay, I was told that we have about 45 minutes, make it around 30, 35, and then we'll open it for Q&A, so we'll see how that goes. I just kind of wanted to set stage, maybe take really quick 5 minutes to give you an outside of what is cloud, and technology agnostic, as in at this point we're not even looking at Amazon or Microsoft or the Google apps. We're just looking at the cloud. And so how many of you have actually worked or hands-on on any of the cloud technologies? Okay, I see about 4 or 5 of them. Okay, and I've also so really I'm sure it's a no-brainer today. There's been a huge number of articles. There's a lot of buzz around why are we moving towards cloud computing? What is cloud doing? So I just put on my thoughts like in 1 or 2 bullet points to say that really it is about sharing the resources and sharing your application being shared across resources and also resources being shared across applications so that it makes it so much more cost effective and also keep it outside of your premise, making it an independent entity so that it can be a little more stable, so to say. So cost is something, scale is something. So these are all the key tenets of the cloud, and I'm not here to repeat all of them now. But really what we are going to look at today is about what is cloud for we developers here, right? So there are these CIOs, CEOs, or there are these big companies, architects, BDMs who kind of decide that cloud is a big buzzword, we need to go to cloud and that's what we are here for, etc. And kind of trickles down to say, and then in your respective companies or your startups or whatever, you kind of want to choose to see what is cloud, can I just get my hands dirty, why is it even there? So really if you see about for developers, it kind of brings a new set of paradigm change, I would say, new set of APIs for developers to start coding upon. At the back end, they're actually going over REST over the HTTP on the REST to communicate to an application. Say if you want foo.exe, so that's right there. Or do you want to look at a data component? The data could be relational, no relational, so you have NoSQL, big data. These are all big, the latest words which have come up and which are also doing really well, right? So that kind of gives developers that flexibility to say that, hey, I'm not tied into this hardware that I have, or I'm not tied into my closed system in terms of monitoring, in terms of my affordability and in terms of my interest also, but I can actually try a lot new things. So new platforms, new technologies, and of course they need to learn new deployment options because what the black box out there is taking a different form of an XML feed or a different form of a package file. I mean, Amazon will ask for one thing, Microsoft would ask for another thing, Google Apps would ask for another thing. So basically you need to kind of know yourself in terms of your deployment options. So going forward, Again, really quickly, I just wanted to touch upon the key jargons or the terminologies or the buckets on which the cloud computing industry has divided the various interactions to the cloud, I would say, is one is infrastructure as a service. All of you heard of this? Yes? Yeah. So infrastructure as a service is you're typically you're a sysadmin of that machine, and then you have complete control over it. The flip side is you also need to ensure the patch upgrades and all of those components are there. You're the sole owner of it. You're just renting a dabba, so to say. Platform as a service is a little more, I would say, a little more stretched in the sense that it provides two things, in my opinion. So here is details about those big boxes that we put up in the previous slide. So platform as a service targets developers, really. So there is a platform out there. So I kind of say that there is an operating system out there. So when I talk of an operating system out there, I'm saying that I need to execute my foo.exe. So I need some component to execute my foo.exe, right? So that black box there has something, let me say, I could choose to call it compute. So it has something called compute that will, when I give my foo.exe in the format that it can understand, it will do whatever the package tells it to do. If the package is a website, it will host it. If the package is a gaming component, it's a service, it's a, could be a Silverlight component, could be any kind of services. It just does that operation. The black box can also have certain other things that an operating system inherently needs, right? It needs various data abstractions. It needs ADTs like flat files, blobs, tables, queues, symbol tables. It would need messaging components. So it needs various storage abstractions, and that is what we're going to take a look at today when we talk of data as a service. So there are data components as a service which I can consume. So that's another thing. The heartbeat of the operating system really is resource allocation, memory management, failover. It's basically the OS tasks is to maintain the health of the operating system and the applications that run on it. So in that way, I also have something I could say as a controller. In the Microsoft's world, I call it the fabric, but essentially any cloud computing component needs to have that basic thing. So that's also there. And finally, it needs some sort of user interface. Could be command line, could be a GUI, could be any such thing to interact with this front end. So it could be, on one hand, could give you directly REST API so that you could code against. Could give you a, say, beautifully designed HTML page so you could just click and do your operations across the cloud. So these are the key things that I might look forward to a cloud. So if such a cloud is there, and it gives these APIs outside for me to go and deploy my foo.exe, for me to go and use a data as a service, for me to put something there and ensure that the fabric is going to manage and it's going to be healthy, and I can also interact with it, I would call that component as platform as a service. Now I'm just spending a little bit of time on platform as a service here because it's kind of not so I would say there's been a lot of confusion around it over the years, so just wanted to kind of spend some time. Software as a service pretty much been there for over a decade in different forms, starting to be called as, right from those web services days 10 years back. It's basically any business functionality which is exposed over HTTP and you can access it. And if that business functionality is an end user's cakewalk, could be Gmail, I would say, could be software as a service. So moving ahead. So this is something that I put up like today morning, and I thought it kind of brings some context to what we're talking, right? Here, just pausing one step here and just trying to explain to you guys why are we even going through the cloud part, and I'm going to maybe spend about 10-15 minutes on the cloud part. So just going to tell you guys why are we even doing this, right? Primarily because how many of you use MongoDB? See, I expected that. How many of you have used CouchDB? Okay, the same hands come up. How many of you have worked on Solr, Lucene? Okay, few more hands. All right. So I assume most of you are open source. How many of you are on .NET platform? I think that will also be an interesting question. Right? So this is exactly why I came from. I knew that most of us are kind of open source here, obviously, and we are comfortable with various things which are available there. And my interest today really is to actually show you in action how all these platforms can be integrated to a cloud. Now, the cloud that I'm going to show you, because of what I know, which is the Windows Azure, so obviously I'm going to show it to you on Windows Azure. But you can obviously extrapolate this because everything is at a REST-based endpoint URI to any other cloud platform that you choose to. Now, when we say any other cloud platform which we choose to, we need to understand what the heck is the cloud, right? As in, what is agnostic or, a company agnostic architecture of the cloud. So that's what we've put up here. It's we call it like the typical cloud architecture. You can go and look at various companies and try to match whether that's what it is. It's basically came out of the research papers which have been done a long time back, just to understand what is a scaled out architecture and what kind of works. So kind of intuitive. In fact, when you see that, you will say that, does this need researchers to actually see this? It is kind of intuitive, right? Meaning, so I don't want one box here. I want a data center out there which is going to service my request, whatever that request is. So, so it has a load balancer. So you have requests coming through that. And then your application can be deployed in one VM, or it could be deployed in multiple VMs. So I call it one computing node or multiple computing nodes, as be it. And then ultimately that node needs to talk to other services, meaning other nodes, or it could need to talk to storage components, data services. That's the bottom line. And all these things need to be maintained in a very healthy fashion. And you have the administrator, and you also need to, for a cloud, there's always the proactive monitoring is something very, very important. So you need monitoring, you need logging proactively. So all that is an entire vertical by itself. So that is typically the cloud architecture. The key things that we are going to focus in our demos today is really about the compute, meaning we can deploy our applications on. Today you'll see it being deployed on the Windows Azure platform, which is the cloud computing platform from Microsoft. But then really you can deploy any kind of applications. That's what we're here to say, because the platform is open. So we could say that it could, if you have a Java app, if you have a PHP, Node.js, you have Hadoop, pretty much anything can run on the Windows Azure platform. The platform is open in the sense that it is the source code for the SDKs which are installed on Linux, which are installed on Windows, and which are installed on Mac are available for download. Individual service SDKs, as you see. Now, if you see, why am I trying to dissect this? I'm just trying to tell you that each of these services that you say, for example, in the cloud architecture, we said computing nodes. And then we said storage components. And we said these are the two big buckets, and that's what you see on the screen. You have computing nodes, wherein if you have a web app, you will just deploy it on a web app. It could run on the computing node. I'm just giving an example. And then you have databases and storage. Databases, relational, non-relational, entity-based, flat-based, file-based, etc. So that is one part of it. Now, all these are available as independent services outside of the cloud computing platform. Azure exposes it at various services. Amazon will expose as various services. But really, at the end of the day, you're getting a HTTP handle, and you can secure it using certificates. You could be a hash key for you if you want it, etc. And then you can interact with those independent services. So that is how it is. So if when you talk of computing nodes, you can say that if you're creating an entire architecture and you have a presentation tier and you have a huge amount of heavy compute intensive processing that needs to happen, and you want to keep these independent on one another, you could do that, meaning you could scale this up and down independent of this. That's when we say these computing nodes can come in variations. It could be hosted on a web server. So in Microsoft world, if it is hosted on a web server, I call that computing node as a web role. I'm just saying as a terminology. If it runs outside of a web server, in our case, the web server is IIS, obviously, and IIS can run across fast CGI is enabled. It can run across technology. So in that, if it runs outside of IIS, we call it a worker role. So your applications can be deployed on IIS, outside of IIS, in different virtual machines, can be scaled up and down independently. So those are some of the key concepts of the cloud that we probably need to have and set in stage before we go ahead. Now let's understand the same thing from the Windows Azure viewpoint. So it's typically the same cloud architecture as you say, only that I just introduced the web and the worker role. So there are different flavors of the compute component which are available. The web role runs on IIS, worker role outside of IIS, and these are platform as a service, meaning you want to interact with these. Strictly, you will be interacting using REST-based calls or using APIs. APIs on .NET, APIs available on Java. and PHP, etc. So you'll be interacting with some SDK in some form. Now, the third bucket that you see up there is infrastructure as a service, meaning you're getting a VM out there. So in the third bucket, you see you can set up a Linux VM, you could set up a Windows VM. So it's really about what machine you want, and then you kind of get that machine and you're the sole owner of the machine and you can do what you want with that. The data components which you see there are the data components which are available outside, out of the box. But the most bottom part that you see, which is other Azure or external services, I think that's what we're going to see here today, right? So from the Windows Azure platform, you have certain data structures which are available, which are whatever mentioned here called SQL Azure. It's a relational SQL server on the cloud. Tables is like your big tables or S3 of Amazon, etc. So then you have blobs, you have queues, and then you have CDNs. So apart from that, any other service which wants to talk to the Windows Azure can do so. So that's that. So at this point, I think I've done quite a bit of talking. So I'm just going to quickly show you the Windows Azure portal and the website, and then we will see how we can deploy. In fact, today we are trying to deploy 3 components. We'll deploy CouchDB, we'll deploy MongoDB, and we'll deploy Solr on the Windows Azure platform. So let's just see how the portal looks like, what the platform has to offer it. So unfortunately for the group here, this is the management portal, and I think I need to log in again. So let's refresh the page. And it needs a live ID today, so you need to log in with a live ID. And once you log into a live ID, it opens the Windows Azure Management Portal, is what it is called. Now, this portal is designed and developed using HTML5, so it works across form factors on mobile phones, on iPads, etc. So that way, it's kind of clean and easy to navigate with. Now, really, this is just a front end. The back end, which is called a Service Management API, which this interacts with, is the REST-based API to talk to every single component that we spoke in the first 10 minutes about. Right? So you can just make a direct REST call outside of the portal and do a bunch of things. In fact, that's what we're going to do today. We're going to use a command prompt and use a couple of these PowerShell commandlets which we have and try to do a direct talk to the Azure component without using the portal. But we'll use a portal to see the outcomes so that we see how it is. So these components that are loading on the left-hand side that you see are the independent services I said. Although I'm trying to tell you cloud computing is an operating system on the cloud, there are independent services available which you can choose to use one independent of another. So if you see, there is websites, there is virtual machines, there's another thing called Windows Azure Mobile Services, which helps you to build a middleware between any kind of a front end, could be an iPhone, Android, could be Windows 8, Slate, Surface, etc. And then you have the cloud services. Today, that's what we're going to see. This is platform as a service component, having the web and the worker roles. And then there is databases, there is storages which is available. And then there is networks and extra certain higher level services which are there. Now, if you see this portal, just wanted to tell you that it's kind of easy to navigate and understand. So just go ahead and say, I want to create a new compute component, and I want to create probably a new cloud service, and then I want to create this cloud service, and then I want to create this cloud service as, let's say, FOSMate test or something, and then just see that it's a unique DNS entry, so it's going to check whether that domain is available, and then I choose, for example, something called an affinity group. If you want your data, your web applications to locate in a physically closer location so that the performance is enhanced, as opposed to having one thing in US while the other thing is being placed in a different location, so that you can create logical entities called affinity groups. Interest of simplicity, let's choose something close to India, let's choose Southeast Asia. I could do something like Solr, which is just a subscription ID, then goes ahead, and that's about it. So I've got this service created. That means I've got a placeholder for me. When I open this app, it tells me that it gives me two options. I have a production space and I have a staging space for me to deploy my foo.exe, right? So I could go and upload here. So I said there's a portal which says upload here. When I click on upload, it asks me for a logical name and it asks me to give two files. So this is what I said. When I say platform as a service, you have to give the platform in the language the platform understands, right? Those are the deployment options. This platform will understand two files. One is a config file, which is just more like a configuration file to say I need so many instances, I need this size, and those can change on the fly without pulling down the site, right? So those are just configuration changes. The top package that you see, package file, that is really the package file. So we have installers, or we have EXEs that will package your application. If you develop on Eclipse, it will package to the package that Windows Azure understands. If you develop using PHP, it will package to the Windows Azure format that understands. So that's the interoperable thing that we're talking about. So those are some key things, placeholders I'm just throwing out so that we have in place that this is how you go and upload your applications, and when your application is uploaded, you can go and take a look at it. Now, an interesting thing is, although it is platform as a service, once you go ahead and upload your application, you can even remote access that application. So that's just gives you a flavor that although you cannot do all operations on the remote VM because you're not a complete system admin, but you'll be creating a local admin account on that VM, and you can go and take a look at it, see the event logs, and be pretty much feel as if it's like your own machine, so that you can basically debug better. Okay, so that's about the portal and the various storage components. But before I close this, I just wanted to tell you the second thing. So I spoke to you about the compute, which is hosting foo.exe. The second thing that I wanted to quickly say is about the storage. So in this case, let's open up Mongo Store. I've just got these deployed in place. So if you see, it gives you access to blobs, tables, and queues. So in our demo, we'll be using the blobs because blobs are really binary large objects, huge number of, it's like huge data being stored, and you can just store up to 100 TB, a single blob. Now, so what are we using is anything that you interact with the Windows Azure inherent at the backend stores it as a blob, and then it's going to read from there inside. So that's a very important infrastructure. Okay, so so that's about that. Now, one thing before we continue, I just wanted to draw your attention to windowsazure.com. So this is your one-stop place if you're interested in Microsoft cloud computing and you want to try to build something for Windows Azure. You want to just start looking at it, and in fact you want to look at only one single place, and that's this. You don't need to look at anywhere else. So it gives right from you can go to develop, and it kind of gives you options if you're a .NET, Node.js, Java, PHP, Python, any kind of a user. Let's open up, for example, Node.js. So then when I open up Node.js, it then gives me the various tutorials and how to get started on Node.js. And then similarly, when I can do Java, for example, then it kind of gives me all of these. It gives me separate downloads. If you have a Mac, you can download that. Linux, you can download this, and then you can download the various. You also want to see that, hey, I've downloaded all of this. How does the source going to look like, etc. So you can just open it on the GitHub, and then the entire source is available for you to take a look. Pull requests are enabled, so you can submit, and it's a very active community from the Microsoft team out there. So this is pretty much every single component on the Windows Azure is hosted on Git. In fact, CouchDB, Solr, all of them are on Git, and that's what we're going to do. So that's that. Now, going back to the portal, just wanted to tell you that we have all of these, and then if, for example, if you want to go to the community and post forums, so that's something which is active and right there. In fact, if you see today's news is that Windows Azure to be extremely prevalent in MongoSV, a Silicon Valley MongoDB forum, so they are active there as well. Now, the other thing is the Manage Center, which is for each of these components that you build, you want to see how to manage them. I want to understand some intricate fundamental details of what is happening behind the scenes. I want to take a look at that. This is a good place for you to start. If you're worried about the cost, and many people are worried about cost when they think of Microsoft, right, is basically you can go and take a look at the various costing components and then how it is, and everything is very transparent. You can actually slide your slider and say this is what I'm going to be charged and how it is going to be charged. It gives you a 3 months free trial with no spending limits, etc. So those are those features. So that was a really quick round trip, and given that we have like 15 minutes, I'm going to go back to the presentation here and move ahead. And these things we already spoke. We said we just wanted to know what is the storage which is available out of the box. And we said these are the two main storage components being available, which is like SQL Azure, and it's also the storage like the blobs that I spoke about. Now, I also wanted to bring to the notice that Windows Azure is a completely open platform. So, interoperablybridges.com is a place you might want to go to take a look at the various projects done by Microsoft. And most of them are done on Azure, because when the Azure product team started building it, they built it as an open platform. So, you can see a lot of work which is being done there. Similarly, Git is a place where you can go and take a look at for a lot of Windows Azure resources and direct contact with the developers who have been building it. Okay, so now let's come back and take a look at how we configure or how do we enable Solr on Windows Azure. So Solr and Lucerne are go hand in hand, and they are all Java-based components, and they need to be and they are being used by enterprises, right? Even a lot of Microsoft customers, and we recommend them to Microsoft customers as being one of the fastest and the most efficient indexing engine out there, and which will really help you to save load on the SQL database or any other database that you use. So you can have a middle tier, a web role on Windows Azure, which will do all the indexing, and then which can then help you to crawl, etc. So what am I here trying to build? I don't know if I can just read out something and that will make sense to you. But essentially what I'm trying to build here is make two compute nodes. So I'll be running for example, I'll be running a primary Solr, which will do basically the indexing of the website that you give. So if you give a website, or if there is a handler for SQL, whatever you do, it will index the site, and it will create it into the schema that you have fed into. And that's the primary. And when somebody wants to search the indexes to make the search, this is replicated to a secondary that will do the search result. So secondary can be extended, meaning there's one primary that keeps doing the indexing. Every time the indexing is over, it replicates to the various secondaries. And end users who want to do some searches on the Solr will look at the secondaries, and they will get the results back. So in fact, this is how, I'm sure you guys knew it. I learned it a couple of weeks back. So that's how it is. And how do we build that on Windows Azure? I said the Windows Azure needs two components. It needs a config file, and it needs a package file. So I need an installer that I can chunk or churn my Solr code to the Windows Azure platform. Interest of time, I'm going to show you how the end result looks like, how it is working, etc. Obviously, very detailed documentation, sample source code is already available. So, so if you see here some of the files that I have. So in the Git, you can just go and search for Solr on Azure, and so you will get a bunch of code that you can pull out. So first, some of the key things that needs to be there is first, Java runtime needs to be installed on a third party, right? That is number one. Now, if it is a Microsoft VM, it doesn't come with Java out of the box. So you need to install Java there. Now, Java doesn't support people to just download and install if you don't allow it using an UAC or enter your credential, right? So which means that you need to actually upload the JDK also, so that your installable is uploaded there, and then it just installs right outside. So I would need to go first and download a couple of packages. Like if you follow the steps, you'll see that I need to first download the Solr core. We have tried and tested for 3.6.1. Maybe next week or something we are releasing for 4.0. But essentially, the output of our Solr project application will be changed or churned to a CSPKG file that you see here, and a configuration file that you see there. Now, in this case, we have two worker roles, meaning two secondaries and one primary. So if I open up the web role, this is just a web placeholder, a website to browse for doing the interactions. Now, if you see these two worker roles, one of the worker role will be a primary, which will do the indexing. The other worker role will be basically the search result provider. So those are that. And these are the schemas and the data configs which needs to be uploaded, and these can be changed based on your indexing options that you want to do. So then I go ahead, and once I have, so first and foremost I go ahead and download this from Git, and then I extract that. and then I need to just run a simple installer, which was going to, so once I go ahead and extract all of this, and then I have XML which I write, which is what is basically going to be followed. So I'm going to do a lot of operations, which is like I'm going to say, go ahead and provision a virtual machine there, go ahead, download a node.js package for Azure, go ahead and download JRE essentially, and various such things. So, and ultimately kind of seals off by saying, just ping back the Solr and check whether your endpoint is active when it's working. So all these have been created into a bat file, PowerShell commandlet, so to say, and then I go ahead and just say that I need to execute this against a particular configuration path that I have. If you see here, this is the name of the unique domain name that we need to create. So here we just created a domain name, I think, which said FOSS. Yeah, do you remember what I created? Test, is it? Okay. So we just did that, and then there's a subscription which is being attached to that and a location where you want to deploy that into. So once I do that and enter, it's going to just fire it off and start downloading the setup from Solr website, and it's going to start doing the operation. Now it is about, at least given the fact that we have to do 2 virtual machine installations, it's a little bulky at this point. So that is one of the flip side. It takes about almost 150, 180 MB to upload, because it's actually uploading the entire Java runtime and associated test components, etc. So however, once it's uploaded, I just want to show you this. So in the morning, I just did the same thing. I uploaded it here, and this is, once it's uploaded, this is what it will look like, right? So the Windows Azure portal will then host the Solr components, and then you will have access to the web app, which is your handle. And if you see, there are 3 cores, meaning there are 3 machines which have been allocated to that. And so I can go and take a look at, I can do a bunch of operations. I can enable diagnostics configuration. I can add linked resources if I want to. So here I have the scale. So it says that I have 2 worker roles and I have 1 web role. The web role is to take a look at the interaction, and the worker roles are at the back end. So, and then as we go and open this up here, this is my web role, and this is actually Solr running on Windows Azure. So here, if you see, there are we've just enabled these operations that we can do. So in fact, let's go and delete all the data which is there on Solr. So we have blank. And then you can go and, if you created a schema that you have, which you want to use, you can upload that. Otherwise, the entire Wikipedia site just created a dump on that. So that has, you just imported that. And then you could go and search for any search item on Wikipedia here. So I could go and say India, and I could search, and this will actually, so, I need to delete all the data, deleted, I need to, so this is successful. I can now go and search for these. So refresh the slave status. If you see, there is a difference in the index size of the master and the slave, right? So that is the essence of really the NoSQL journey of all the products which are available, right? So there is this the base concept as opposed to the asset concept, right? Wherein you really don't have this real-time concurrency, however, availability and eventually concurrency is guaranteed. So if you see, the master has already indexed whatever site that we have given, and then it has created that site. Now the slaves are trying to get updated, and you just saw that the slave has now got updated with the exact size of the master. So kind of both of them are in sync. So we can go to the search, and now you can search for an item. And typically, if you see now that both of them are in sync, we get everything from Wikipedia. So it's basically crawling to Wikipedia. Or we could just, now you can, for example, you can go ahead and, I'm going to go ahead and delete all the data once again. Anybody out there who want to give up your blogs, blog URL, blog sites which have anybody has actually built your own blog engine here? Yeah, you want to just tell me, we can validate it. Blogs.blog or blogs? Right, so we can try that. blog.hasgeek.com. Say start crawling, and we'll see whether, and I think regarding the interest of internet, and I'm going to cancel this operation because it's taking way too much bandwidth out there. So if you see, these are the blogs that you have written. So it's actually crawling through the various blogs that you have written. Now, the resolution is not helping. I can't get the scroll bar out there. So if you see, it will just go ahead and quickly index your blog, basically index your blog site. And then once it's indexed, we can then see the crawling is completed. It's indexed. It's a small site. So I can just go ahead and, you want to tell about any particular blog of interest that you have written? So we're going to get a lot of entries, I'm sure, if it is JS4. So here we have JS4. So there is a couple of entries on JS4 which has come out. So this is a simple, just an illustration of a simple indexing, and you can do that, and everything is running out of Azure. So that is one thing that I just wanted to show. The other thing is, obviously, for those of you who worked on Solr, you kind of want to have that granular control and change the schema. You want to have the admin control to the Solr, right? So the admin site is also right there. So we can go and take a look at the admin site out there. So just need to go to this admin URL, which is written here. So we could go here and let's go to the admin portal. And then you'll see that, or I'm just going to make my life simpler than I have. So here you have the Solr admin portal where you can go and do a bunch of operations out there. So that was Solr on Windows Azure. Quickly changing gears and moving to CouchDB on Windows Azure. So similarly, there is a common installer on Windows Azure. Just go to Git and look out for install for Azure, or you could just look out for MS Interop. So that will give us all these components that I'm talking. So then once you just run the installer there, and you can also open and take a look at the code inside, and you can set up your URL, then you get your CouchDB on Windows Azure. Now, this is a Node.js front end where they're just displaying the details out there. So you're having Node on Azure as well. Now, let me clear the clutter just for a second. And then you also have, similar to the Solr thing, you have the admin portal for Couch. So you have that here. You can go and do a configuration. You want to set up your replicators, check out the statuses, add some test cases. You could do all of that right outside on the portal. MongoDB is supported by Tension directly. So all of these things that I told you, we actually wrote these drivers from the Microsoft's end. So MongoDB also is a great candidate. So you can see that, again, in this case, we have one primary and one secondary. So a document-based search engine wherein I think we've actually tried to, so this is the document that I have put. So I just essentially just got one document, so I can just go and create another movie, say Talash, and say it was released today, right? Okay, so it's today, and the genre is thriller, and just putting a price of a movie ticket these days, and go ahead and create. So all these are created, and now you can now you could take, for example, here I could go and say drill into one of the databases and then see whether what is the total. So whatever operations that we have done, for example, to insert it using an MVC. So this app which is here is a simple ASP.NET MVC app. So I'm using that to basically insert some data, and then here I'm going to see whether the data is inserted and what is the status, has it been replicated to the slave, etc. And essentially that is also happening. So I think at this, just going to take questions, just wanted to kind of show you these things in action. Pretty much all of them are easily discoverable, and wanted to summarize what we saw today. Just wanted to kind of get that clear that most of things we saw today was on the cloud platform, to say that the Windows Azure platform kind of supports all of these. And the key takeaways is to say that a platform is open, it's available on Git. You can try to host your indexing, search index of your interest. You could host various data components. Today we just quickly, at least we just had the time to see the end user effect of Mongo, Couch and Solr. You can change all of that. In fact, we've done a case wherein we have actually got the CouchDB components, and we've actually crawled that using the Solr, and we've got a customer implement all of that. So from the Microsoft's point of view, I think this is really useful for us. So, and also out of the box, you have drivers and plugins for PHP, Java, Node.js. Maybe I could take a question if there is time. 2 minutes. Yes. Right. So basically there's choice. So there are, out of the box, there are 5 flavors. So you have, the MongoDB I ran today was 2 medium primaries and 1 small as a web front end. So the sizes are extra small, small, medium, large, extra large. So starting from about 1 GB to about 18 GB is on the portal. Now if you want something like 32, 64 or even more than that, it is available. You'll have to request for it and you'll be given. You can't just go sign up and take it as of today. Because also if you see, the Windows Azure platform is honest to word, it is basically it came pretty late. It's on the catch-up mode. Meaning that the Windows Azure platform 4 years back, it was completely platform as a service. They had not even thought of a lot of things that we do today, basically giving a VM, making a Linux VM, things like that. So when they are actually exposing all of these, I think more than 18 today is not available immediately. That's a simple answer.
Yeah, that's pretty good.
Thanks. So hope it was useful. So thank you so much. And if you have any questions, you can write me at SHARN779. I'm going to be here for some time and happy to talk to you. Thanks.